Chris, have you organised more beer and pizza?
Yeah, definitely more pizza and definitely more beer. Yeah.
Good. I'm sure that's what all of you mostly care about, but don't worry, more is coming. I'll hand over to Kee.
All right. Thanks everyone for coming. I guess it's kind of nerve-wracking because this is like kind of releasing our baby, something that we've built up over the past couple of months. Simon helped me with the white paper and stuff, and having it out in the ecosystem now is like pretty big for us. So yeah, go easy. So it's called Loki. Who's heard of Loki? Can you put your hands up? Okay, so some of you. Cool, so who I am, Simon introduced me before, tech lead on Loki, lots of stuff with the white paper. I studied technology at Monash, a little bit of computer science, but my majors were in cybersecurity, cryptography, and networking mostly. For me, it's been like a kind of a big journey, kind of getting into kind of crypto stuff. And it's been good having these guys around me and supporting me. So the project. What is the project? So why do we need Loki? This is like one of the most kind of important things about the project. So private corporations and governments are collecting more and more data upon us every single day. So they're not just collecting data on Facebook or LinkedIn or the social services that we expect them to collect data from. They're also moving to blockchain services as well. So there's a US government contract out right now with chain analysis and Blockseer, which are basically, they look at the Bitcoin blockchain and they trace funds through there. Mainly it's for the IRS at the moment, but very soon they'll be looking into kind of criminal activity on blockchains. And what they define as criminal activity is not always criminal activity in Australia. So a lot of these oppressive governments, I don't want to mention any names, but China especially doesn't like their citizens, engaging with each other in terms of protests for the government or information that's being shared around. So governments can essentially come after these people and monitor them, and blockchain is becoming a way to do that as well. If you've looked at the Bitcoin blockchain, you know that every single transfer that you make is on the blockchain forever. It's immutable, it's there, and it's public, so anyone can see it. So that's kind of why we need privacy coins. I'll discuss a bit more what the difference between Loki is and some other privacy coins. But centrally, Loki is about private communication and also private transactions. So the other thing is decentralized networks. So a lot of the private communication systems have been handled. So we have stuff like Telegram, which does end-to-end encryption. And WeChat is doing end-to-end encryption as well. Or yeah, like there's lots of them out there. But the thing that they don't do that Loki does is they don't have decentralized hosting. So Telegram servers can be shut down. And we saw this happen in Iran a couple of weeks ago. So there was big protests in Iran, and basically the Iranian government said to Telegram, you have to shut your servers down, and they shut their servers down. So no one in Iran could use Telegram after that. We're trying to build a system that is resistant to that kind of attack. So there will be no way for a government or third party to take down these servers. And I'll explain how we do that a bit later. This kind of architecture has been proposed before, and it's kind of what Tor does, right? But we're doing some different things, which mean that governments can't just spin up thousands and thousands of nodes and do timing analysis attacks or own a percentage of the network, that they can infer what people are doing from that ownership. So how Loki is built. So it's fundamentally two different technologies mashed together. So the private median for transactions, that's all based on Monero. So you've probably heard me talk about Monero before. I run the Monero meetup on Mondays. And Monero, we believe at the moment, is the most private transaction layer that you can harness. So that's why we're building off Monero. We're not building a fork from Monero. We're just taking its source code and using the best underlying parts of Monero and making some modifications to that code. So it's not like we're trying to do a split where there's an original chain and then an orphan chain like Bitcoin or Bitcoin Cash. We're just taking the source code because we believe it's the best way to do things at the moment. And the second layer is the nodes on top of that, which allow us to route private messages and basically build a protocol layer where we can connect different people. And that's kind of built more off the Dash masternode system, where you incentivize nodes to run, you give them money paid in Dash usually. That's in the Dash system. And then, so we use that system except we pay the nodes in Loki. It's a lot different from Dash in that we actually can use these nodes to do meaningful things. So Dash pretty much has private and instant send, and no one really harnesses them. The system that we're using just builds a protocol layer on top of the incentivized nodes. So you can essentially do with those incentivized nodes what you want, and we're going to hand that over to the open source community. The first application that we're going to build on top of these incentivized nodes is messaging. And once you can prove messaging can be done on top of incentivized nodes, then you can essentially build a protocol out from that. It's pretty complicated, but there's a white paper out there which kind of goes through everything here. It's 18 pages, and it explains all of the technical concepts behind this. But it is possible at the moment to build a layer of incentivized nodes on top of a private currency where you can use those nodes to route private messages. And once you can route private messages, you can route data and you can do anything with them. So that's kind of where we're coming from. That's the beautiful kind of architecture that you can build with something that's a hybrid of Dash and Monero. You can actually do private transactions securely instead of just using CoinJoin. And you can use these nodes that you have all over the world to route any data you want, essentially. We're just starting with messages, though. So snaps. So this is the idea of, so first we start with messaging. So that's called Loki Messenger. That's the first app that we build on top of these nodes. But similar to Ethereum, where they have dApps, which are decentralized applications, we have snaps, which are service node applications. The applications that are actually built on top of those nodes. So they're decentralized, they're unstoppable, no government can come in and shut down any servers because they would have to go to individual people who are being incentivized to run nodes and tell them to take down their nodes. And we expect with the way that we're rewarding nodes, there'll be thousands and thousands of nodes. So they would have to literally individually contact every single node runner and shut them down. And that's a monumental task for any government, let alone a consortium of governments coming together to try and do that. We just don't think it's going to happen. So they're different from dApps in that all of the communication for snaps happens off-chain. So you have them being incentivized on-chain with Loki payments, but all of the transfers of data and messages, that all happens off-chain. So basically, yeah, we're just creating this layer of nodes that are rewarded in an on-chain token. And the best way to reward them is obviously Monero, because it's the most private token out there. So yeah, they're censorship resistant, and that comes from the fact that no government can really shut them down. We don't have any control over what people do on our network. Even if a government came after us as a foundation, we wouldn't be able to shut down the services that are actually running on there. So we don't have any more control than any other party in the system. They're scalable because they happen off-chain, not on-chain, and everything's open source. So you can go view the source code that we write. We should have a testnet up in the next couple of weeks. So this is kind of an overview of how the system works just visually. So you'll have the blockchain running as usual, like any blockchain. And then you have service nodes and nodes. So we're still going to allow full nodes to participate on our system, but the service nodes are actually the one that do the interesting stuff on our system. So they're routing messages between each other. So you can see if Alice wants to send a message, send the message to 3 random nodes, and then Bob can recognize that message by querying the service nodes that are running and asking if there's a message that relates to his public key. And then he gets given back his message there. This can be done in other systems. It's just no one has really taken this to the next level of actually incentivizing the nodes to run, and then being able to put high throughput through these nodes and route messages through them. So the team, Simon explained this before. So we've got Simon, Josh up the back, and Chris over there. The part that he didn't really talk about is we have some pretty heavy-hitting developers. So we have Thomas Wingent. He's the person who's done the third largest amount of commits on Monero. He's got 120,000 lines of code in Monero at the moment, and we've got him on board for our project. So we're not really lacking in development resources, and that's why we can launch a testnet so soon, just because we have the people behind us And mainly those connections were developed through connections we had from the Monero community. So it's all kind of just coming together for us. And we have Andrew as well. So he's a PhD mathematician. He's doing a lot of kind of third-party research into bulletproof implementations into the system, and some really cool technology that Monero has proposed but hasn't merged into their code yet, and we're looking at merging it possibly before Monero does. Cool, so that's just the kind of broad overview of the project. I'll open it up to questions now. Yeah.
But for example, WhatsApp has like, what is it, a few billion messages every day. Can your network handle that too?
We can't say anything for certain right now, but there's going to be thousands and thousands of nodes that are incentivized to run on our system. And because we're not doing things on chain, they should have the same capability of any server to route messages between them, just like any server does. The thing is, once you have these nodes set up, as long as the incentives are in place for them to run, then they can be running on high bandwidth kind of architecture, and also be communicating with each other at high speed as well. The main problem is that if you have nodes that aren't incentivized, then you're going to have nodes with poor hardware. But if you incentivize them, then you can get high-powered nodes.
If you're basically forcing them to have the throughput necessary to participate. We do this through a trustless quorum system where we actually get a bunch of other nodes who are incentivized to provide an accurate test. So basically, if other nodes can route dummy messages through those nodes, they can be pretty confident that that other node is performing at a desirable level.
Yeah, so you won't get paid if you don't have a high-powered machine, basically. Yeah. Yeah.
You said that the messages are stored off-chain. How exactly are they going to be stored?
They're
So-
stored in the service pool, service node's individual mempools.
Yeah.
And they're stored for a 24-hour period. So if messages remain unclaimed for 24 hours, they can get dropped off. And the way that's enforced is when other service nodes are testing other people on the network, they can leave their messages there for up to 24 hours. And if they don't get their message back, then they're obviously going to get flagged. Which means that there is an incentive to hold that message there for at least 24 hours.
Yeah.
So if you don't pick up the message after 24 hours, it's gone?
It's gone.
Yeah.
The idea behind the system is not that it is the best messaging system out there. On the contrary, it's for those times when you need to be absolutely certain that the message is not going to be read by anyone else, and you need the absolute pinnacle of privacy. We're not expecting that this is going to be a competitor for Telegram or WhatsApp or any of the other messaging applications out there. This will be things like when you're sending confidential contracts, or you're in a foreign country and you're worried about the government there, so on and so forth. So there's many different use cases, and we'll of course also be setting up bridges as well. So you don't necessarily need to have both parties using the system. You can route part of your message through the system, which connects to an email server in your home country, which can then send a regular email, for example.
And you can do stuff like witnesses as well. So like at that point, you can do something off chain where you essentially say to someone, "Oh, can you store my message from the mempool?" and then you pay them with Loki as well. So you can delegate, stuff as well. We're just not going to handle that on chain.
And on the device?
Sorry?
So I received a message. Is it self-destruct, like with your app, with the app?
That's all client-side stuff. So
Yeah.
once you've got the message, it's up to the client software to decide what to do with it.
Yeah.
By default, it can self-destruct if that's a box that you decide to tick. But yeah, all of these features that are going to help build the privacy, we're thinking about it, and it's going to get up on the front end.
Yeah.
How about because you're using the public key to put a query in and then retrieve the message, but it's a public key. So if I know your public key, I can collect your messages.
That's correct, but you can also create a new public key for every message that you send.
Yeah.
So there are ways to churn it, and again, this is all handled on the client side as well. So there are ways to get around that. The problem is that you also need an identity.
Yeah, it's encrypted as well. Like, so you can grab my message, but you can't do anything with it. Like, yeah.
Yeah, but if I create a bot that creates unlimited amount of public keys and tries to
Yeah.
query.
So so we have a system to prevent this. So this is runes. So they're basically to communicate on the network, you have to have bound to you a pre-computed proof of work, which is called a rune. Basically, it's a proof of work that would last, we're saying, around 24 hours on a computer to use the service for 30 days. You can either pay for that if you don't have the computer to produce that, but if you have a powerful enough computer, you can produce the rune yourself. You bind it to your public key, and then you're able to communicate on the system. So it prevents us against SQL attacks. Yeah.
What algorithm are you using for that work?
It would be crypto night, I imagine. Yeah.
We were exploring alternative consensus mechanisms for the rune chain itself because it is a secondary blockchain. It is questionable whether or not Cryptonite will be the best algorithm for it, but Loki itself will remain Cryptonite coin along with Monero. And that's mostly because it presently is the most successful cross-device hashing algorithm. So it's as efficient as it is on modern CPUs as it is on modern GPUs. Yeah. And there is a lot of talk right now about changing the hashing algorithm slightly because there's rumors out there that there is a Monero ASIC. But our stance on this is that if it comes to light that that is the case, we'll tweak the algorithm so that it always remains an equitable hashing algorithm. Yeah. As Monero is doing as well, I should add.
Yeah.
Are there any limitations on the size of the messages you can send? And if not, what's to stop people from overloading nodes by sending messages that are too big?
We will have a set message. The great thing with what you can do with runes is you can bind a rune to a public key, right? So you can set limitations on what that public key can submit to the network. So whatever
without having to
identify yourself, So essentially what it means is that we can set reasonable limitations based on what the service node network can handle, and we can do testing. We've got a performance engineer on our team to work out what the network can actually handle in terms of message size at that point.
A few questions. First one is, what's the approximate ETA to when the mainnet gets launched for people to start mining?
The approximate ETA is probably 2 weeks, would you say?
2 weeks.
Yeah. 2 weeks and you can start mining.
But that's dependent on a few things on our end. It's sort of like there's no real time expectation on this. We're just going to do it when it makes the most sense. Of course, we'll update everyone in the community.
On the Telegram.
As we become more certain, but at this stage 2 weeks is our best guess.
Okay, cool. Second question, are you going to be able to send files as attachments with the messages, or is it going to be text only?
Not yet. So that's like another kind of system that we're developing. So the first thing is to develop Loki Messenger, and then the team will develop snaps after that, and we're also going to hand the protocol over to open source development as well. Exactly, yeah.
And last question is there going to be an option for people to pay additional Loki to have their messages stored for longer than 24 hours?
Yes, we've thought about that.
Okay.
We thought so once you have runes in place, you can essentially do what you want and charge what you want with that system. So we were
going to be protocol side or peer-to-peer based?
Peer-to-peer based, mostly peer-to-peer based.
What we're doing is we're enforcing a minimum standard.
Minimum of 24 hours, and then if you want more, then you can pay the
Correct, but nodes will optionally be accepting that service.
So will users choose which nodes they send to, or will that be a random process?
For maximum privacy, they should actually choose random.
Yeah.
They should use the deterministic ordering based on the hash of the last block to select which nodes they're going to store their messages on.
So if they're sending it to random nodes, will they have to make long-term arrangements with a whole bunch of nodes to store their messages for 24 hours?
Absolutely not.
Or will they just send to one that stores it for a long period of time?
They could do that so long as that service node accepts them. So we might see a situation arise where there are certain service node operators that offer
specific transactions.
not sensor-specific transactions that actually provide a service above and beyond the minimum standard. Because if you catch people that are censoring transactions, using the trustless quorum testing system, because everyone that's running a service node is incentivized to punish everyone else.
Crab bug mentality.
You can use the trustless quorum system. So the idea behind the trustless quorum is this, is that if you get 5 or 6 people to answer a question, and they know if they get the answer wrong, they're going to get punished. Basically, they're going to answer correctly. But if they go out and say, okay, you guys are testing that node, and then they go out and they get a bad response back, meaning that they don't get their message routed back to them after 24 hours, they can all come back and say, no, we are not confident that he is performing correctly, and then in the next block he'll be punished.
And that gives them an additional reward because it takes a higher percentage of the reward.
Exactly,
It gives it to the people for telling the person.
The more people they remove,
Nailed it. Write the white paper for us.
I didn't write it, I just read it.
We actually haven't added that bit yet.
It was a good one. Yeah, you guys should pop that in the second.
That'll be in the revision.
Yeah.
You pass the second edition by me if you want to look.
We will.
So, well, sorry, we'll just answer this one and then go to this one. Oh.
Two questions. Why is it called Loki? And does it have anything to do with the advisors in the team?
No.
It doesn't have anything
Yeah.
to do with the advisors of the team, but you're talking about JP, aren't you? Because his last name is Thorbjornsson, which
Yeah.
is a Swedish name, and that's relevant because Loki is the Nordic god of mischief.
Yeah. So it's a play on words, right? Low key, as in the two words, like low key communication. Yeah. So that's the name.
At the start, I think.
Yeah. Question up the back.
What's the base level of anonymity service node?
Sorry, I didn't quite understand the question.
So someone's running the incentivized service node.
Yeah.
Is the wallet achieve like a basic level of anonymity?
So
This is unique to Loki, actually. The way Dash does it is that the public key is fully known, the balance is fully known, you can audit it on the blockchain, you know their IP address. In this system, we use a system called bulletproof declarations, where we actually get a range proof that is traditionally used in Ring CT with Monero, but we're actually using it to prove that nodes have a certain amount of Loki that they can use to stake with. But what that does is it actually doesn't require them to reveal a transaction on the blockchain. So they can still have their anonymity protected and their transaction history protected by publishing a range proof to the network. And we also are going to implement the I2P router that's coming out on Monero called Covery, which is basically going to mask IP addresses for everyone operating the network, not just the node operators, but also everyone sending private messages and stuff. You'll be sending packets of information between cryptographic keys rather than IP addresses, which means that there should be a high degree of anonymity between members on the network across the board.
And you won't be able to geolocate.
yeah.
Correct.
Well, once Covery's in, yep. Yep. Block size. It's dynamically scaling, like Monero is. So no set block
Based on
size.
median
Yeah.
transaction size.
It's also a weird question because Monero transactions are huge. They're like 13 kilobytes by default. So it should scale up to a reasonable degree. Once bulletproofs are implemented,
Yeah.
that transaction size shrinks a lot. But yeah, it's a dynamically scaling block size. So as the traffic on the network increases, so too does the block size. And what that would normally mean is that you get an enormous blockchain whenever people actually start using the network,
Yeah.
which is happening to Monero. And what it means is that people that are running nodes take days to sync, lots of bandwidth to try and store it, lots of disk space. But in our system where the node operators actually pay to operate, that should be a small cost relative to the rewards they can earn from the staking. Yep.
So say this takes off, you achieve all your goals. What would the cost in Australian dollars be to send a message?
To send a message,
There's-
0.
There's no cost. So you have a rune attached to your public key, which gives you yeah.
Okay, say you didn't use any computing power to, if you bought your room,
Yeah.
what would that cost?
So the main we can't tell what it's we can't tell you what it's going to be, but the main protection for the price of runes going up and down is that runes expire after 30 days. So we're hoping that there won't be a large secondary market for something that's so kind of intangible and it's going to be destroyed anyway. Yeah, and the idea is also that the Loki chain will always be more profitable to operate on than the rune chain. So there won't be tons of incentive for someone to be mining runes and selling them in a secondary market, which probably won't drive the price of runes up.
Unless
But
there's
yeah.
insane demand for
Yeah,
the Loki messaging network, which we can hope and pray for. And if that happens, we might have to rethink how the system operates.
Yeah.
But if we look at systems like Tor and I2P, the reality is that they are niche tools. And we
Yeah.
expect that Loki will be a niche tool, but it'll be a very good one.
Yeah. Yeah.
The hybrid proof work with someone at the step
So miners do, so the block reward is split, right? So 55% of the block reward goes to miners, 45% to stakers, and then 5% is for a governance block. So the stakers in the system, or the proof of service nodes, the service nodes, they get paid a percentage of the block reward.
Well, that's 105%.
Oh, sorry. What?
45 for service nodes, 50 for miners.
But-
So you mentioned burst the other day.
Yeah,
Spoke about burst. What's the proof? What do they have?
Proof of storage.
proof of storage, yeah.
Proof of work uses a lot of energy, right?
Yeah.
So is that going to be the case with this?
So the idea for proof of storage was to use it for calculation of runes. We're still looking into that. So the idea, I suppose, is that you wouldn't need a large amount of computing power to calculate a rune to send messages on the network. You just need a hard drive that you could prove you were storing data on, and then that data makes it easier to mine. That's at least the idea behind proof of storage. It's not really been implemented in anything other than Burstcoin at the moment, but it's an interesting consensus system that you can use to produce more egalitarian proofs. That's the idea, at least. That's what we're looking at. Middle?
So the room is allowed how many people inside?
So, sorry, what was that?
The rune allows one address.
Yeah.
That address can be one person, it could be one company, it could be one anything, really.
Yeah.
It doesn't really matter. There's no identity checks on it, so it's just one user on the network.
Yeah.
One email address.
So not you can't include a group of people, like they can have a meeting?
No, you can include a group. It just means every single one of them has to have a rune attached to their address.
Everyone have the room there.
Yes.
So then also they can communicate in the same time. Everybody can see the message, can share.
If it's a share.
But it should be A to A, or A to B, B to C, and A to C like this. Or
So-
they can.
Are we talking about group messaging
Yeah.
here, as in group chats?
Group
Unfortunately, this won't be possible in the current design of the system. It may potentially open up, but it's level of complexity that will come after
Yeah.
the peer-to-peer messaging becomes available.
Yeah.
Only text message or phone message or like make a call. The two people have the room.
Potentially, if this becomes a service that allows for just general network routing, which is potentially possible, we could use this as a VoIP system as well, but for the moment it is just going to be text messaging.
There is possibility to do groups on this. You can do it with something called topics, which mainframe uses as well. So there is possibility in the future. It's just what we're building initially as the proof of concept is an end-to-end encryption service, which would allow me to send Simon a message. That's the first thing we're building. After that, the possibilities are endless.
Like we said, this isn't something that we're trying to build to compete with the big chat apps. That's what the big chat apps are for. What this is for, and you'll find this is the case in Telegram and WhatsApp as well. When you do an end-to-end encrypted messages, it's only between two people. So this is group messaging in a secure way between several parties is something that is actually very difficult to do in a secure way.
It's possible, but it's very difficult.
How you have to do it is you have to basically have a system where each individual user in the group is sending a peer-to-peer message individually to every user, and you just aggregate it at the end on the front end. But it's in practice a difficult thing to do. All right, I think we might...
We'll just take one more.
Okay, one more.
I think you had in your diagram you had to fill with polling the messages. How quickly like a message delivery be in the system?
Yeah, we haven't tested the system extensively yet, but it's just a query. So it's a query like you would make to any other
it should
server.
be as fast as email is
Yeah.
what we would suspect.
Yeah.
So not instantly fast. There's not a node sitting on both ends of the transaction ready to make that message transfer happen immediately. But it should be a polling system that you see in much the same way email operates.
Every time you just refresh it, it'll pull your new message.
Exactly, yeah. Yeah. Oh, one more. That's the last one. You can come to us afterwards
Yeah,
and
I'll talk to you.
yeah.
How does the mechanism work? So I was reading there the Loki white paper, and you explained that there's going to be a separation of powers between the Loki Foundation and the Loki development team, whereby there's a dichotomy where the Foundation funds the development team, and the development team can choose to hard fork the address of the Foundation if there's a conflict between them or if anything goes wrong. How does that system work?
Well, it's an open source project. If the people that are doing the development decide that they don't like the people that are paying them, then they can obviously change who is paying them.
Yeah.
That's just the mechanic of open source operations. But also, the other part of it is that obviously if you're controlling who gets paid, you can just pay different people.
Yeah.
It's a pretty simple idea, but it does create this two-tier dynamic where you can have, obviously everyone's got different interests. The foundation wants to make sure that the people that are operating the project align with its core principles, and the people developing the project obviously want to do certain things, and also they're obviously going to be aligned with the core principles.
Yeah. So if you're making it an open slather for the developers to hard fork the Foundation of Will, what stops the main developer from hard forking to their own address and becoming, in a sense, the Foundation?
Well, nothing really, but the miners
So
in the
that won't
community have to accept it.
I mean, you
So the
can
idea is
do
like-
that with any crypto system out there at the moment. So It's the lead developer or will have access over the GitHub and can push, software out there that people download and it'll fork the. Like
The
you'll
idea
still
is
have to
that
have
the
community
foundation goes
support,
wrong.
right?
So if the community widely accepts
Yeah.
that
The
we
foundation
become
start, right.
absolute evil people and just start
Yeah.
spending money on Lamborghinis and stuff,
Yeah.
then obviously the developers who are working on the open source project just go off and create a new chain.
Yeah.
with-
But you're going to need support for that chain as well. So like
You'll
the
need,
community is going to need to
this
agree.
community
Yeah,
support.
exactly. The community is going to need to agree about forking the address as well.
Yeah.
All right, we will leave it there. I believe. Wait. Oh, thank you, Will. Thank you. Yes, I'll take that applause. Thank you very much. Now, Chris. Where's Chris?